Hey, what's going on, guys? Let's do this problem right here. The question is asking what must be the diameter of a cylindrical 120 meter long metal wire if its resistance is to be 6 ohm. The resistivity of this metal is 1.68 times 10 to the power of minus 8 ohm meter, right? So they are asking for the diameter, and let's list all the given information. Here we have the length, that is 120 meter, and they also have given the resistance is equal to 6 ohm. Also they have given the resistivity, that is rho, that is equal to 1.68 times 10 to the power of minus 8 ohm meter. So we have all these informations, and they are asking for the diameter. And also if you look at this one, when we have rho r and this length, we know that the so whenever we see these things, we can remember this equation, that is R is equal to rho L over A, right? So this is the equation comes into mind. And they are saying this is a cylindrical metal wire, right? So here we have, this is resistance, resistivity, length over area. So here since this is a cylindrical metal wire, the cross-sectional area is going to be a circle, right? So we are going to use the area of the circle. So that's going to be pi r square. Since it's, if you want to write in terms of diameter, this is going to be, we know that radius is equal to d by 2. So this is going to be pi d by 2 square. If you square this one, you will get pi d square by 4. And we can replace this a with this value right here. So we can replace a with this value. So let's replace this one. So this is going to be R is equal to rho L over pi d square by 4, right? We can bring this 4 to the top, and that's going to become 4 rho L divided by pi d square. Now let's look at this one and see whether we have all the information. We have the resistance provided, we have the resistivity that is provided, we have the length that is provided, phi we don't have to know, and d square, that's the question. So let's rearrange this equation and find the d square. So if you rearrange this one, you will get d square is equal to 4 rho L divided by phi r, right? And this is d square. To find the d, we just have to square root them. So this is going to be square root of 4 rho L over phi r. Let's substitute all the values and see what we get. So here we are going to have 4 times rho, that is 1.68 times 10 to the power of minus 8. So this is going to be 1.68 times 10 to the power of minus 8 times L, that is to 120 meter. So let's get rid of the units for now. So as long as everything is in SI unit, the final answer is going to become in meter. The final answer is going to be in meter, right? So let's maintain everything in SI unit. We have the rho that is in SI unit, ohm meter, and we have this resistance, it's in SI unit, that's ohm. And let's put the bottom values. We have phi right here, phi is a constant, and R, that is 6 ohm, right? So this is meter, this is 6 ohms times 6, and then if you calculate all these values, so this is going to be 42.8, except this 10 to the power of minus 8. We can take this one out. Like if I take this one out, that's going to become 10 to the power of minus 4. And then if you calculate this one, you will get 6.54 times 10 to the power of minus 4, right? That is almost equal to 0.65. This is meter. So this is equal to 0.65 millimeter, right? Because 0.65 times 10 to the power of minus 3 and 10 to the power of minus 3 meter mean that's equal to millimeter, right? That's how we got this value. Therefore, this is our final answer. D is equal to 0.65 millimeter, and that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.